Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. Today we're going to go ahead and finish up the second half of the 5.2 notes. The one thing I would recommend to maybe have nearby as you work through these is at least the first page from 5.2 day 1. We're going to use a lot of those formulas again, so having those handy will definitely be helpful. So what we're going to do first is, if you even remember on your 4.3 identity sheet, the complement or co-function identities. Those are identities we don't use as often, but what we're going to do is we're going to let you see how these sum or difference formulas actually allow you to verify those. So if we ask you to verify an identity, again, we're only going to work with one of the two sides. The side we're going to work with is the cosine pi over 2 minus x. We're going to use pi over 2 as alpha. We're going to use x as beta. And we are going to use the cosine difference formula. So the cosine of pi over 2 minus x will become cosine pi over 2 times cosine x plus sine pi over 2 sine x. Now we're going to use some exact values to continue simplifying. Well, cosine of pi over 2, when you refer to your unit circle, I'm not going to grab that for the simple one, but cosine of pi over 2 is 0 times cosine x. The sine of pi over 2 is 1. And so then that cancels. All we are left with is sine of x does in fact equal the sine of x that we were supposed to have it equal. So there is one example of using one of those actual identities along with the formulas. Now the next one, cosine of theta minus 3 pi over 2, it's going to work a lot like the one you just did, other than the fact it's not a given identity. So once again, here is our alpha, here is our beta, and just like the one above, it is going to be a cosine difference formula. So when we use our formula, we're going to have cosine theta, cosine 3 pi over 2, plus sine theta, sine 3 pi over 2. Well, again, going to your unit circle, cosine of 3 pi over 2 is 0 plus sine of theta times the sine of 3 pi over 2 is negative 1. Well, cosine of theta times 0 cancels. All that is left is negative 1 times sine of theta, which is negative sine of theta. So this is one where you're simplifying, unlike the first one where we were showing the left side equaled the right side by verifying. One final example on this page, tangent of theta plus 3 pi. Well, again, for this we're going to use one of your tangent formulas now. We're going to specifically use the tangent sum formula. So for that, we are going to have tangent theta plus tangent 3 pi over 1 minus tangent theta times tangent 3 pi. Now there is one issue that we do have here, and that is, tangent of 3 pi. Well, when one full rotation or revolution is 2 pi. To get to 3 pi, that will be 2 pi plus pi. So essentially we're working with what is the tangent of pi. So for that, tangent pi equals tangent 3 pi, which again, if we're looking at sine over cosine, well, at pi, the sine is 0, the cosine is negative 1, so that is simply 0. So when we now plug in, you have tangent theta plus the tangent of 3 pi is 0 over 1 minus tangent theta times 0. Now again, this works out real nicely. That cancels, and all we're left with, tangent of theta plus 0 is tangent theta over 1, simply leaves us with tangent theta. So you can see that once you get the hang of how these difference and sum formulas work out, they often work out to fairly nice, neat answers. All right, a little different style of question here for example 3. Now it says we can use this to actually solve it like an equation. Find all solutions in the interval from 0 to 2 pi, the sine of x plus pi over 4 plus the sine of x minus pi over 4 equals -1. Well, what we are going to actually have to do here is use our sum and difference formula for sine. So we are going to have an alpha and a beta here, an alpha and a beta here as well. So I am going to actually put the formulas at our reference. So for the sum, that's going to start out sine x times cosine pi over 4 plus cosine x cosine pi over 4. So that takes care of our first half of the problem, plus now we're going to use the sine difference formula, which will actually allow us to cancel some things out here in a moment that you'll see. So then we have plus sine x cosine pi over 4 minus cosine x cosine pi over 4, and that does all equal that -1. So from here is where things will actually start to shrink down a little bit for us, but what we can now do is cancel these two terms. We have sine x cosine pi over 4 plus sine x cosine pi over 4. Well, that becomes 2 sine x cosine pi over 4 equals -1. From here, now, there's a couple of different ways you can go about working with this. I am going to go ahead and actually plug in our exact value to sine x. Now, cosine of pi over 4 is radical 2 over 2 equals -1. Well, what we can do from here, the 2 here and here will cancel, so now we have sine x equals, with the radical 2, I'm going to go ahead and move that out to the front. I think it works a little easier if you do that, equals -1. Now, from here, we're going to get sine of x by itself, divide the radical 2 over, sine of x equals, now, I am going to have to simplify the radical, so that becomes negative radical 2 over 2. If you notice, when it says we are finding all answers in the interval 0 to 2 pi, so this is going to involve some of our exact values. Sine of x equals negative radical 2 over 2, so basically what this is referring to when we use our unit circle. Sine is your y value, so we're looking for every spot on the unit circle where the y value is negative radical 2 over 2. So certainly as we look through the circle, the two spots where that happens, because it did say 0 to 2 pi, we do want to go ahead and use the radian values. First, x equals 5 pi over 4. The other place where sine is negative radical 2 over 2 is also at 7 pi over 4. So that's a third way that you can actually use these sum and difference formulas. Now, one final question. Example 4 is not going to be a unit circle question. This one's going to have a couple of different things come up here, and we'll talk a little bit through what's going to have to happen here. Now, for this cosine of u minus v, I'm going to set up the difference formula first, then I'm going to come back, talk a little bit about how these work and the fact that it's in quadrant 2. So if you have the cosine of u minus v, again, here is your alpha, here is your beta. So this becomes cosine u cosine v plus sine u sine v. Now, the nice thing with this, half of what you need is given to you. The problem is half of what we need we are going to have to solve for here, and that's what we'll talk about in a moment. Cosine u, cosine v. Well, the good news is we have cosine of v. We also have the sine of u, so I'm going to put the negative 3/5 in for the entire cosine of v, just like I put the 5/13 in for the entire sine of u. Don't put that in place of just u. Now, we do not know the sine of v. Now, here is where we're going to have to set up a right triangle in quadrant 2 for each of these. So I'm going to do this over here to the side. Now, again, it does say both are in quadrant 2. So I'm going to start with angle u. It says sine is 5/13, so that's opposite over hypotenuse. So we do have to find the adjacent, which we would do using Pythagorean theorem. So 5 squared plus a squared equals 13 squared. Well, a squared will equal, just doing a little bit of quick, 169 minus 25 equals 144. So the adjacent side, when you take the square root of 144, is 12. But again, keep in mind, it's in quadrant 2. So our adjacent is negative 12. So when we are looking for the cosine of u, what we are going to now do, that is negative 12 over 13 times negative 3/5 plus 5/13. The last thing that we now have to do is again set up another right triangle in quadrant 2 to find the sine of v. It's going to work just like what we did a moment ago. Again, I'm going to set up my triangle in quadrant 2. Cosine is adjacent over hypotenuse, negative 3 over 5. This is a Pythagorean triple. I am not even going to set up Pythagorean theorem here. The opposite side is 4. So the sine of v is 4/5. Now we can go ahead and combine our fractions. Well, negative 12 over 13 times negative 3 over 5 is 36 over 65 plus 20 over 65. And then when you add those up, it is 56 over 65. And probably the good news is that does not reduce. So the cosine of u minus v is 56 over 65. Again, just as a big reminder note, usually the most common mistake here is, notice when we give you the sine of u is 5/13, plug that in for the entire sine u, not just u. Sending with your cosine of v. That is negative 3/5. It's not the cosine of negative 3/5. But that completes 5.2 day 2's notes. Again, much like 5.2 day 1, the work for this is on Pearson.